Properties and structure of matter.
Hello class, my name is Sabeeha and this is Hiaydee. In this video we will explain the main features of the major types of chemical structures like covalent molecular, metallic, covalent lattice, and ionic networks.
Covalent molecular substances. Covalent molecular substances are discrete molecules made up of non-metallic atoms, which can exist as elements, such as oxygen gas, or as compounds such as water. Covalent molecular substances are also comprised of neutral molecules, which means that they do not have ions or electrons. The absence of these mobile charged species means that these substances are unable to conduct electricity as pure substances or when dissolved in a solution. The molecules are held together by weak intermolecular forces which are easily broken and overcome. Because of this, covalent molecular substances are soft in solid form as their particles are easily distorted. Additionally, they also have very low melting and boiling points as their molecules are easily separated. A well-known example of a covalent molecular substance is water, otherwise known as H2O. The water molecule as a whole is neutral with 10 protons and electrons, and does not conduct electricity as pure water. Water has a low boiling point of 100 degrees Celsius and a melting point of 0 degrees. As the molecules are separated so easily, this must mean it has weak intermolecular forces holding its molecules together. Other examples include ammonia, hydrogen gas, and carbon dioxide. Metallic substances. Metallic substances are comprised of rows of fixed positive cations in a repeating lattice. These cations are surrounded by a sea of delocalized electrons which keep them from repelling each other. Altogether, these mobile charged species allow for the conduction of electricity. Metallic substances have variable melting and boiling points. Although there are some exceptions, most metals have high boiling and melting points as a result of the strong metallic bonds holding their particles together. These bonds are the electrostatic forces of attraction between the positive ions and the negative electrons. Depending on the strength of these bonds, they will require certain amounts of energy to break. For example, the melting point of copper is 1085 degrees Celsius, which is extremely high in comparison to the melting point of mercury, which is only 39 degrees. Copper will require large amounts of energy to separate its particles, while mercury will only require a small amount of energy. Metallic substances are also malleable. This is because of the flexibility of the sea of delocalized electrons, which are able to shift into different arrangements with the positive ions while still holding the structure together. When force is exerted onto the substance causing it to change shape, the positive ions in its structure will not repel against each other, due to the sea electrons surrounding them, which will continue to hold them together while the ions are rearranged.
Covalent networks. Covalent solids are a class of extended lattice compounds in which each atom is strongly covalently bonded to its nearest neighbors in a network arrangement of non-metallic atoms. They are hard but brittle because of their inflexible covalent bonding. Covalent network substances have high melting points due to the many strong covalent bonds within the lattice structure. A lot of energy is needed to break these covalent bonds, resulting in a high melting and boiling point. Furthermore, they cannot conduct electricity because they are comprised of neutral atoms. Examples include graphite, diamond, and silicon dioxide. Last but not least is ionic networks. An ionic network consists of oppositely charged ions held together by electrostatic forces arranged in a three-dimensional array. The ions are held together by strong ionic bonds. There are no discrete molecules in an ionic network. There is only an infinite array of positive and negative ions. For that reason, the formula for an ionic network specifies the ratio in which the ions are present. Examples include sodium chloride, sodium fluoride, and ammonium nitrate. Ionic networks have high melting points due to the many strong ionic bonds within the lattice structure. A lot of energy is needed to break these ionic bonds, resulting in a high melting point. Ionic networks are hard because of the strong electrostatic forces holding the oppositely charged ions together in the lattice structure. If we try to distort the crystal, we will bring like charges together and they will repel one another, hence being brittle. Ionic networks do not conduct electricity in the solid state because the ions are held in a fixed position. In the liquid state and in solution, ionic networks can conduct electricity because the ions are mobile.